recommendations at Videoland will be presented by Mateo Granada.
Yeah, my name is Mateo. I'm a scientist at RTL, and today I will take you to one iterative improvement cycle where you will see a transformer model and some Bayesian optimization. So welcome to Videoland Universe, the biggest Dutch subscription-based video-on-demand platform. Videoland counts with thousands of local and international content and over 2 million users. And we started off, you guessed it, with the matrix factorization for explicit feedback, trying to reconstruct the binary signal. But soon enough, we realized, well, I mean, it's much more abundant, the implicit information, and through the same methodology that I will describe soon, we realized that combining the implicit and explicit information was beneficial. So we combined this in a signal R tilde from 0 to 1 that is mostly a very naive mapping from a dislike to 0, a like to 1. If the item is a movie, we would use the completion rate. If the item is a series, we would use a logarithmic transformation of the completion rate so that we would boost a little bit that completion rate. Say a user has spent streamed 3 or 4 items for episodes of a series, and well, the completion rate is still low. We wanted to boost that. Maybe the user is a bit hooked already. We also add an exponential decay so that the importance of this signal decreases with the time. And note that the exponential decay does not affect the explicit data. We use the loss function of weighted matrix factorization. And we solve it through ALS, so I will refer to this, or baseline, as the ALS model. So Videoland will look something like this. You would have a strip, continue watching on the top, some other strips, and a strip that is fully personalized with the recommendations for each user. The recommendations would be, under this model, the highest predicted completion rate. We deployed this back in 2018 against editorial curated strip, and we observed 30 more minutes of viewing time. But we wanted to harness other source of data, in this case, the sequential information. So we observed that we might have users that might stream the same items, but at different moments in time, maybe with the same completion rate. They will finish all the items, but they would look very different sequences. So we conjectured that, at least within Videoland's data, there would be information encoded in those sequences. So we formalized the problem by transforming the long sequence that describes a user into fixed length sequences of size, let's say, L. And we would use also the rating that we construct, this R tilde, along with the sequence. We would allow sequences of at least 80% of L, and we would pad the rest. And we would also collapse identical consecutive user item pairs, like in this example. So we, of course, tried with many different sequential models. We used BERT for rec, but no glory there. But we modified some of these models to finally reach this architecture, where we would use the user, the sequence of items that the user has consumed, along with the ratings that we have created, or well, we have observed. And we will let the encoder of the transformer learn the representations. We will add 2 different heads, one softmax to learn how to predict the next item, or the probability for each item to be the next one, and one sigmoid head where we would predict, or learn to predict the rating. At the training time, a few elements in the sequence would be masked, and those elements would be predicted along with their sequences. And in this way, we bind together the next item prediction with the score or rating prediction. At scoring time, we would use the last sequence for each user. We would append a dummy item at the end. We would mask it, and then that would trigger the prediction for that one item. Exposing this model, Bertos, with only one head, with only the softmax head, and as well as with the two-headed version against the ALS model, yields slightly better results in terms of offline metrics like recall, NDCG, and mean average precision. But most importantly is how this behaves online. So as a subscription-based service, Videoland tries to optimize for retention. But retention is affected by many factors, and sometimes you can only observe the effects very slowly. So we consider metrics that we can influence more directly, and we know from customer churn patterns that lower viewing time is indicative of likeliness to churn. So for the A/B test results, we consider a lot the viewing time and the consumption in the analysis. So we have 4 main metrics. Promo to paid as the proportion of users that had a promo account and turned into a paid account. The stream rate, the number of items that a user would consume to a certain completion rate, 80%, per average per day, or on average per day. The viewing time on average, and churn as the proportion of users that had a paid account and decided to cancel their subscription. When we have events like counting the successes on Bernoulli trials, like it would be for the promo to paid or churn, we can observe that this follows a sort of binomial distribution. And from the Bayesian inference approach, we can introduce a prior on the rate to actually get a posterior probability given the observation of the data. So this holds for the promo to paid and for churn. For the stream rate, we also observe that the counts would follow a Poisson distribution. If this is the case, then we can introduce a prior for the rate, a gamma distribution, and again, we would have a posterior of the rate giving the observed data. If you have these properties, you can actually calculate analytically the probability of, let's say, a rate Q of promo to paid or churn under a given model, a treatment model, to be better than this metric under a control model. And the same holds for the rate lambda for a Poisson distribution. If you're curious about the proofs, just ask me. I don't think I will have time to go through them. So for viewing time, it's very hard to get a posterior probability with an analytical form. So we avoid this, and we just do a slightly weaker, or with more assumptions test, t-test with a significance level. So once we do this test, we observe that Bertos two heads compared to the ALS model has a statistically significant difference, small, but statistically significant. The only one out of the 2 BERT variants. Well, here I have a point estimate and a confidence interval, but no distribution. Whereas for the promo to paid, if we compare Bertos with the ALS, we have a distribution. We can realize the probability of the Bertos to be better than the ALS. In this case, I would say it's not high enough probability to declare a winner, but we have it and we can use it to assess risks if we are to, I don't know, do other, say we want to use it, but maybe, yeah, we can give a number to this at least. If we compare it to no recommendations, then we observe that the difference is much bigger, above 2%, and the uncertainty has been trimmed a little bit. Now the probability is 0.92%. You can see the distributions diverging a little bit. For a stream rate, comparing Bertos with the ALS, we can be sure to account for most of the epistemic uncertainty here. even though we have a slightly small difference. But we can be sure that, okay, with almost 1 probability, it's better. For comparing Berto's 2 heads with no recommendations yields more or less the same results with just a higher difference. To summarize a little bit, comparing the transformer-like model with no recommendations, we observe differences statistically significant in 3 out of the 4 metrics. Churn, we could not spot any difference in none of the models. It's harder. But for the other 3 metrics, we observe a difference with respect to no recommendations. And with respect to the ALS, we spot significant differences in 2 of the metrics. And at least we can assess in some way the other one. And just to take away, we experienced in the past that it makes sense to combine implicit and explicit information. And now we observe that, at least in our setting with our data, extracting some sort of information from the sequences is valuable. And we can harness it through a bird-like model. And yeah. So I take now a couple of questions. Thank you.
Thank you for your presentation. I see that there is one question, please.
Thank you for the really nice talk, Mateo. Brings me hope also to see concern about, let's say, long-term retention of users. I think a long time in this community we've been talking about how click-through rates are simply not enough. Do you think we're solving the right problems? And by that I'm asking you, should we, and purely financially this is completely fine, but is it better motivated, for example, to decrease churn or to retain the customers you already have? Where do you think we can find the largest gains?
Isn't it decreasing churn the same as retaining the customers that you already have?
My apologies. So somebody who is going from promo to pay versus someone who has been pay for a while and fear of losing them, if I'm specific there then.
I can only give you my personal opinion about this, and I think that if you have a big rotation, a big chunk of your users are coming and leaving, then you better focus on retaining the ones that you have. There will always be a portion of the users that after some time just decide, okay, I'm not using the service that much, I'll leave. So up until a certain point, you better decrease churn, but then better also focus on attracting new people. That's what I would say.
Thank you. Next question, please.
Thank you for the presentation. So my question is about the sequence that you are considering. So if I take an example of a user, then are you considering the sequence that whatever he watch in a month or something, or like in a session? So
in the period of observation, so it's longer than a month. It's not
okay,
a session.
So
it's not session-based.
So your assumption is that if user have sequence, then he will go through the similar pattern afterwards also, so after 1 session or 2 sessions?
Not necessarily that, but when you're consuming, let's say, a series, you might do it in a way that you consume 1 episode every week or 1 episode every day, and maybe you interleave this or with another series, yeah? So maybe from that we can extract some information, or maybe you just focus on 1 item and then you are done with it and then go to the next one. So maybe this kind of information is what we are attempting to capture.
Okay, yeah, thank you.
Okay, I guess we can take one more question with a quick answer, maybe.
Okay, I'll try to make the question quick as well. Bob van der Velde, Dutch Public Broadcasting. I was wondering, as I understand it correctly, you have both implicit and explicit feedback. And I was wondering how big of the difference is there, and is there information in the fact that you have explicit feedback or not?
There is information, I would say. I mean, we actually try to override. So if we have the explicit feedback, then we will not use the implicit one. Yeah? What was the first one that you?
So I was wondering about the information gain you have from explicit feedback and whether there's information whether you have it or not in itself. So if people rate something, they might like it more or they might be really not liking it.
So back when we started, we tested only with the explicit feedback, only with the implicit feedback, and also with combine. And through the same kind of methodology, we observed that it was better to use both. So there is something there.
Okay, thank you.
Okay, thank you. There is one online question that I want to mention very quickly. Is it possible to predict retention by using other observable features that are measurable in a shorter time perspective? For instance, engagement. I guess that then the primary problem to solve is finding the right indicators for retention. It's from Francesco Ricci.
I fail to see what the question is.
Is it possible to predict retention by using other observable features that are measurable in a shorter time perspective, like engagement?
I don't know. I guess we will need to figure out.
Future work.
Speculation, yeah.
Okay,
I
great.
would say yes, but yeah.
Okay, thank you.
Thank you.
Thanks for your presentation. And the next speaker is Camille Roth. Follow the guides. Disentangling human and algorithmic curation in online music consumption.
Thank you. Thanks. So I'll be presenting this work with my colleagues Quentin Villermet, Jérémy Poirot, Manuel Moussalam, and Thomas Louaille. I'm Camille Roth. And this work takes place within the broader debate on the influence of recommendation on user taste and consumption, and notably its diversity. And what we want to speak of here is filter niche rather than bubble, in the sense that we ask whether user behavior actually influences the way algorithms or recommendation in general influences their consumptions, rather than the other way around, that recommendation influences consumption. And we want to essentially show that there is no blanket answer to this question of the influence of recommendation on consumption. Oops. So next slide. Thank you. And so typically the reference point here for algorithmic influence is the organic one. That is when users choose autonomously to navigate content. And there's also another point of reference, which is the traditional human-mediated recommendation that takes form in our case where we study music consumption, the form of playlists, human-mediated, curated playlists, and also another point of reference which is interesting here and which we study in the paper is the case of radio programs, which is also traditional human-mediated guidance. The data we use is the data stemming from one of our partners, Deezer. So we have the complete listening histories of users, and we have those three types of affordances: the algorithmic access, the organic access, and the editorial access. And so we want to show that there are user types here. But first, let me step back a little bit on the literature here, the filter bubbles, and this decade-old intuition that there are filter bubbles. There's been a lot of work on this, and the state of the art at the moment seems to say, okay, it's not very bubbly. I mean, there's a wealth of studies in different platforms with very different protocols that are relatively hard to compare with one another that seem to say, in general, okay, algorithmic use is associated with an expansion of the horizon of navigation. There are some exceptions, especially in the case of explicit preferences, that is when users specify that they want to subscribe to specific content, for instance, and in which case research shows that it seems to constrain users in a smaller environment. There are also other exceptions in platforms that are actually similar to the ones where the influence of recommendation has been shown to expand the horizon. And so there is still a little bit of debate on whether it's bubbly, not bubbly. And we contend that one of the ways of reconciling these possibly conflicting results is actually to consider beforehand user types and then describe the possible influence of recommendation based on these different user types. So we specifically do that. We categorize users first. So we have the 3 affordances, as I said. Each user has a listening history, a proportion of plays, listening to songs that are algorithmic, editorial, or organic. So in a ternary plot, they have a position. We use a simple binning, which is based on k-means, to distinguish 4 types of users. Most of the access is organic, but still there are some differences. Each dot is a user, and we have 4 categories. The very organic users, O+, the organic users, green, the predominantly algorithmic, and the predominantly editorial, A, E, O, O+. On the whole, the distribution of plays, the activity on the platform is relatively comparable for one category of users to the other. And from there, we consider 2 dimensions of diversity. One which is relatively structural, which is based on the portfolio of songs that a user listens to, namely that there is redundancy. I mean, comparing the proportion of unique songs in the portfolio to the number of plays. So if it's 1, that means each song has been listened to 1 time. It goes to 0 when a user listens repeatedly to exactly the same song. It's a structural notion of diversity. I also introduce a more semantic one, but let's focus first on this dispersion, so this simple ratio. When we distinguish what happens for the 4 user types, and also with respect to each access mode, so we see generally that dispersion is generally lower as a function of activity. Here, each of the histogram corresponds to a certain value of the S/P ratio, so the dispersion. So when you go to the left, it's a lower dispersion. The darkness of the bars corresponds to a certain activity. And what we see also is that dispersion, so redundancy in a way, is lower for the main access mode of a given user type. For algorithmic users, for instance, dispersion is lower for algorithmic access, and so on and so forth. It's also generally lower, there is more redundancy, for organic access, especially for the very organic users. And we see also that the O users, they appear to have a lower dispersion even in the algorithmic access mode. So what this means is that in terms of the structural diversity, there are already discrepancies in the different users and also mediated by the different access types. The second one is a simple notion of diversity, a semantic diversity that is based on artist popularity. So let's say related to the characteristics of mainstreamness, niche artists. We simply compute, based also on the platform data, 4 bins of popularity that gather exactly the same number of plays over the whole data set. So that means there are a few artists in the first bin, a new one, which corresponds to the most popular artists, and so on and so forth. And so when we simply look at the access modes that correspond to these bins, we see that, yeah, organic access is the majority of access anyway, but still there are these variations. Algorithmic access, for instance, seems to favor the less popular artists. For the editorial access, it's the other way around. It's more popular artists. And the organic access is a sort of U-curve that favors both very popular artists and much less popular artists. And here, if we combine with the dispersion, we also know, we observe that it increases with less popular content on average, which is not unexpected. It means there is less redundancy for the least popular artists. What's interesting now, we say is one of the core results of the paper, is to compare the behavior, let's say the relative proportion of plays for a given bin of popularity for each of the user types. So here we have the 4 user types, and we have a null model where we compare the number of plays that fall in the bin of popularity with respect to what would have happened, all other things being equal, uniformly. Since the bins gather the same number of plays, it's pretty easy. So what we see here is the log ratio here. For algorithmic users, there is a tendency to favor the middle popular artists. It's an increase over the value 0, and so less for the more popular and the least popular artists. For editorial users, there is a tendency to favor more popular artists, and it's monotonous. Organic users, it's the other way around. They tend to favor the niche artists, and O+, it's a U-curve. So we have this average thing. But what comes to be interesting here is to differentiate those phenomena, which are basically relative importances of the popularity bins, with respect to each access mode for each user type. And here we see that the influence of the algorithmic recommendation, editorial recommendation, or organic access changes with respect to the user type. For instance, we see that the algorithmic access, which is the dashed curve, tends to pull or be associated to less popular artists in general, except for e-users. For the editorial users, the algorithm pulls them still towards more popular content. For the editorial access, it's relatively monotonous, and for organic access, it depends. It depends also on the type of users. So to summarize a little bit this picture, what we have here is a landscape of different user types. Of course, these things could be refined, but what matters is that we can associate to each user type a specific subplot that describes the relative importance of such or such access mode with respect to a diversity which is here based on popularity, and that those things are contrasted and do vary a lot with respect to this predetermination, that there is no blanket solution to this question. Some things I would have needed 5 more minutes to speak of, so I didn't include them in the presentation, is our comparison with the reference point of radio playlists, and so to compare whether editorial recommendation on the platform is more or less diverse than the recommendation made by radios. And so we see that there is less dispersion on radios, more exploitation of the catalog, more redundancy, and still there is a wide range of artist popularity. So the comparison is a little bit mixed here. Another take-home message is that the algorithmic access in general avoids popular content, except for the specific class of users, the editorial ones. And organic users, those ones are actually the ones in the middle here, so with a relatively balanced diet of use of the platform affordances, are actually those who focus the most on the least popular content. And so our hypothesis here, in terms of uses, is that these users are possibly the most expert users. So that's something that would have to be confirmed, checked with possibly qualitative research to know which those users are. But this also connects with something that is quite known in the qualitative literature on the use of algorithms, that there are different expectations towards this guidance or such guidance, and that here maybe we have the users who are the most acquainted with the platform. They are using it rather than being influenced by it. And eventually, editorial access, and even more so for editorial users, and especially when we compare with the radio playlists, it seems that it fulfills a role that's traditionally ascribed to radios in terms of this mainstream exploration, the exploration of popular artists, and yet there is still more exploration, a higher dispersion. So that's about it for the results I'm going to be focusing on here. The main take-home message is no blanket answer, but more clear-cut answers if we distinguish beforehand persona, user types, and affordance uses. Thank you.
Thank you for the presentation. Are there any questions in the room or online?
So a question to you about the organic users who are polarized, right, in terms of niche and popular content. Do you think we could categorize them further? And tying to that, did you see the talk from Martijn and you earlier in the conference where they were distinguishing between expert and non-expert users, if I'm construing it very roughly?
I haven't, no. But maybe you can give a few words about the specific thing here that you are alluding to. I mean, what would be key here? So better categorization of the users in terms of adding this kind of dimensions?
Yeah, so
and that could be based on something that's not in the data, I mean, quantitative, but external?
Yeah, so they found that people who were higher in musical sophistication, I hope I'm not misconstruing their work, were more stable in their preferences in medium, short, and long term. If that's the case, then we should also be able to see that in the data without giving them surveys with musical sophistication. And I'm wondering indeed if they're users who are new to the system, who are exploring more, or users that are stable. I'm not yet convinced, personally, of people who are experts are fixed in notions, but maybe this is the case. And,
no, this is a very good point. I don't want to do a sneak preview on another paper that's going to be presented at Izmir, but precisely we looked at also the users on the long term, on 2 years, from the very beginning of subscription. And it was very hard to see changes in behaviors in at least the use of affordances. What was remarkable is that you had a quite fast and stable, quickly stabilized use of, in terms of proportions, of the affordances. And users started to be very editorial. They remained so for 2 years. So that doesn't mean that it's not associated with a change in tastes, exploration of more genres, but it felt like those classes of users, at least, are at a, let's say, higher level in a way, in a level that is predictively quite strong to predict what happens later as a result of the stability.
maybe we can ask you for that preprint later. Thank you.
Sure.
Yes, thank you. There are some questions, online questions as well. I will read one of them because I was thinking the same thing. The diversity considered dispersion and popularity, leave aside music-related aspects which can influence the listening behaviors. For example, artists' popularity is not equally distributed across different genres. Have you explored other diversity dimensions? And in case yes, what have you learned from those?
And so in this case, we decided, maybe this is an important precision, we decided to go against using genres, the labeling that we also have in the data, because we thought it was very unequal and also relatively difficult to deal with, I mean, with respect to what we had here. We also used, in another case, embeddings, audio embeddings to assess the diversity based on this, whereby we could also connect some evolution, some influence with this distance in that space. And eventually, yeah, for this paper, we decided to, for a page limit maybe, to focus on the 2 dimensions that we thought were already structurally and semantically the simplest, and it's still efficient. Mm-hmm. But that would be interesting to work on a higher dimensional space, but also to make sure that some distances are not artifactual. That's what we were worried about.
Yeah, I think I would also be interested to see if different types of users have different properties, such as age and gender differences. Yeah, very interesting. Thank you.
Yeah, and this was also stable. I mean, age demographics, we didn't see any strong differences, surprisingly. Uh-huh. But just to finish. Thank you.
Okay, thank you.